The Web 2.0 tool that we have chosen is called Changing Matter. This interactive web page facilitates quality teaching and promotes learning through a range of features. The Changing Matter interactive games animation allows students to visually witness and explore the behavior and interactions of particles in relation to an object's change in state. The step-by-step animation of ice melting and then evaporating into steam addresses all dot points in the Chemical World 1 strand of the Stage 4 science syllabus, except for Part E. Students observe the changing behavior of particles as heat energy is added to a material. The animation then emphasizes the resulting change in state of the object. The use of ice as a material to explain particle movement creates a real-world connection, as the melting of ice from solid to liquid is a familiar scientific phenomenon. This web tool therefore builds upon students' familiarity of an everyday event, allowing them to better understand particle behavior in a significant and relevant way. Researchers Singer and Sin Kai Wu concluded after formative and summative testing that these types of representations enable students to make transitions between the macroscopic, microscopic, and symbolic levels. Another feature of the web page is the interactive walk through nature. This allows students to increase the temperature of the particles, observe the effect on their movement, and then read the text to understand why this is so. This develops a quality learning environment according to the quality teaching model, as students learn with self-regulation and high engagement. The feature also resonates strongly with dot points C and D of the Chemical World strand. It is an excellent example of a simple particle model which illustrates to students the changes in particle movement with increased heat. This Web 2.0 tool would be most effectively used in an introductory lesson for a unit on the chemical world. A clear and concise interactive particle model such as this one would provide students with a deeper grasp of states of matter at the atomic level and allow them to build on their knowledge throughout the rest of the unit. Used in combination with a range of other macro-scientific models, such as plastic molecular models and diagrams, these models could be distributed between different groups in the class and a rotational teaching method used in the double period of that science class. Micho Tool's Jigsaw discussion group strategy would be an effective way to integrate this resource into the classroom. As students are encouraged to engage in higher order thinking as they articulate these difficult concepts to their peers in small groups, the activity would promote intellectual quality in accordance with the quality teaching model. The summary questions provided upon completion of the demonstration would be applied well in a group work context, with students discussing the hypothetical problems together to develop their peripheral knowledge of the subject matter as well as their problem-solving skills. The resource therefore demonstrates significance from the quality teaching model, with inclusivity and connectedness being prominent features of such group activities. In 2013, Stojanovska conducted research to address high school students' misconceptions regarding this topic, especially related to the vague ideas between the macro and micro world. The authors concluded that the use of animations and molecular models had a positive effect on students, and pointed to the need of introducing, in the chemistry teaching, the new material more visually. The literature highlights how useful visual representations can be when teaching matter. However, it also suggests caution. Ilks, Wittek and Pietzner emphasize this importance outlined above, but also reflects the dangers inherent in employing insufficiently examined, poorly considered, or even misleading visualization. This includes incorrect application of constructivist pedagogy and models that are misleading about chemical phenomena. Our applications of the artifact within a pedagogy outlined above can be very well justified, given the emphasis that will be placed on these visual representations that are accurate scientifically, and furthermore, our supplementation of this one artifact with many others, including plastic models and diagrams. All three aspects of the quality teaching model are evident: quality learning environment, significance, and intellectual quality. We have therefore chosen this artifact because it facilitates quality teaching and promotes learning through strong integration of the quality teaching model and wide research on the topic of enhancing student understanding of difficult scientific concepts at the atomic scale.